Hey guys, in this video we'll take some basic concepts to understand banking of roads. So watch till end and don't forget to subscribe, learn with Sid. Let's start with the video. Hey guys, let's talk about banking of roads. There are two types of roads, in which first type is where the road is exactly horizontal called as level roads, and the second type in which the road is inclined with the horizontal. Those types of roads are called banked roads. Let's consider an object on which a force is applied in this direction. So after that, the box will move in the direction of the applied force. Now let's take another example in which the same object is applied by equal and opposite forces. In this case, it will not move because of equal and opposite forces applied on that. Now let's take another case in which consider a rough surface on which the same object is kept. And if we apply some force in this direction, there is a frictional force generated between the surface and the box. So here the box will not move when the applied force is equals to the frictional force generated. So this is about static bodies. Now let's take a moving body which is moving in this direction. So this is the direction of velocity. Now on this body we have applied some force in this direction. So name it as applied force. Due to combination of these two, the box will move in the new direction in this direction, or we can say that this is the new direction of velocity of that box. So now let's discuss about another case in that the same box is moving in this direction, that is named as velocity direction. And in this case we are applying two forces which are exactly equal and opposite in direction. So because of that, both the force 1 and force 2 will cancel each other and there will be no change in velocity direction. Now let's dive into the topic. Let's consider a car which is under circular motion, or we can say that it is moving in a circular path. And also we know that every object moving in a circular path will be acted by centrifugal force which is acting radially outwards. And also we know that if we draw a tangent to a circle, we'll get the velocity at that particular point. And since there are no other forces acting on that, due to the combination of these two, it will attain new direction of velocity and move in that direction. So now let's consider another case in that the same car is under same circular motion and also it is acted by a centrifugal force which is acting radially outwards. Let's name it as CF as of now. But in this case, there is a centripetal force acting radially inwards, which is nothing but the static friction or the frictional force generated between the wheel and the road, because of which the car will move in a circular path. So now let's talk about the derivation of level roads. So let's consider a level road on which a car is moving in a circular path. And since it is in circular motion, it is acted by centrifugal force which is acting radially outwards. This force will always try to pull the car out of the circular path. And since it is moving on the road, there is a frictional force generated between the wheel and the road. And since the generated frictional force is radially inwards, we can call this as centripetal force. So therefore, from this, we can say that centripetal force is equals to frictional force. And also from the previous topics, we came to know that centripetal force is nothing but mv square divided by r. And also the frictional force is nothing but u into n. And generally on every object, there is a normal force acting vertically upwards. Name it as capital N. And the weight acting vertically downwards, name it as capital W. From this we can write N is equals to W. And also we can write N is equals to M into G. Substitute this in above equation, we can write mv square divided by r is equals to u into mg. And if we simplify this for v, we will get v max is equals to root over mu into r into g, where capital R is nothing but radius of the circle, g is acceleration due to gravity, u is coefficient of friction. So this is an expression for the maximum velocity of a car which is under circular motion on the level roads. So now let's talk about the banked roads. Let's consider a road which is indicated by the green color in the picture, which is inclined at an angle B with the horizontal, and on which let's consider a car which is under circular motion. So when it is under circular motion, it is acted by centrifugal force which is acting radially outwards. So name it as centrifugal force. So now let's talk about different forces acting on the car when it is under circular motion on a banked road. One of the force is normal force which is acting perpendicular to the car, and another force which is acting exactly vertically downwards, which is weight, and another force which is a frictional force generated between the wheel of the car and the road. And now let's resolve this frictional force in horizontal and perpendicular direction. And this horizontal component is known as F cos B, and the vertical component is known as F sin B. And similarly, if we resolve the normal force in perpendicular and horizontal direction, we can resolve like this. Here the vertical component of the normal force in this direction, that is N sin B, and the horizontal component is N cos B. And also we know that centripetal force is acting exactly radially inwards. So here N sin B and F cos B is acting radially inwards. So if we add these two forces, we will get centripetal force. So we can write centripetal force is equals to sine component of normal force plus cosine component of frictional force. So using this concept, we will find out the maximum velocity and also the angle of banking, which we will be seeing in the next video.